tricking me. You're asking Google what the pH of the ocean is.
Siri says 8.2.
Well, Siri is wrong. We're having problems with our spectrophotometric method of measuring seawater. Somehow it's coming out that we are measuring somewhere in the neighborhood of 7.75 pH, plus or minus about 100th, or maybe 200ths there. But pretty close to that. And if we account for the CO2 content and the alkalinity of the seawater, it should be at about 8.02. So we are somewhere in the neighborhood of 2.5 tenths off, which is huge. And I don't know why. You know what the really crazy thing is? We are further off than we were on Friday.
That's correct. It's a Monday.
And I don't know why. Why do you think that is?
It's a Monday.
And I don't know why. Wait, what did we change today? What things did we change?
The seawater.
Yeah, it's different seawater, I guess.
And we bubbled it for 10 minutes and then stopped instead of constant bubbling.
Okay, so we didn't do constant bubbling.
And we put it at, or made each cubit at room temperature before we...
Okay, so we adjusted temperatures. We tried to hold the temperature more constant on it.
Yeah. And it made it worse.
None of those things should have made it worse. That's just weird to me.
Correct.
Let's try some more things.
So we just got to Seabo's and realized that we didn't grab the credit card. So now we're going to do the drive of shame back to Rosario to grab the credit card so we can head back and actually buy the parts that we need. Take two.
I don't think they actually ever fully explain what's going on or the problem that we're having with pH, or our pH measurement in the tanks. Now, measuring pH in these tanks is one of the fundamental things that we need to do, because measuring the pH is going to tell us how much CO2 we've actually gotten into these aquaria. If we don't know that, our entire experiment's in jeopardy. We have a big problem there. So let's take a look here. I have this pH probe in the water here. And if you look down onto the computer monitoring the pH, it's measuring pH here, let's say somewhere in the neighborhood of about 8.18, 8.17. Let's take a look at what happens if we pull this out and just scoop it out into this glass jar. So if I take this, if I just take this electrode and just scoop it into this glass container here, like this, and set it aside, now it's in the exact same water that just came out of it. It should measure the exact same pH. Let's take a look if it did. And what we see here is, no, it's actually jumped way up. It's actually jumped from about 8.18 to 8.21. Actually jumped up a couple hundredths, which might not seem like a lot, but for what we're doing, that's an incredibly large amount. This is the exact same water, and it jumped up 2 hundredths. Yeah, that's not what we want to see. That means that we have some sort of electrical disturbance likely, or a grounding issue in our tank, and this is going to make it very hard to control our tank to the parameters that we want. We need to find a way to fix this. That's one of the major challenges that I still have not figured out yet.
baby mystery over here does eat amphipods. So we're gonna put a couple more in her tank. We put about, I think, 4 yesterday, and they're all gone, so I hope that means she ate them and not that they were able to escape, because they can definitely get out of these. But if she's eating, then that's a positive note.
It is the end of a very slow day at the On-Thank lab, and Chris and I just got back from running our errands, got most of what we needed, and I would say that the big lesson from today is that it is very hard, very difficult to go shopping when you don't have a piece of plastic called a credit card. Except how would I know about that since I am a poor grad student and I have no money. But that's our lesson for today. It's very hard to go shopping if you forget the credit card for the lab. This is Mo, over and out.
Don't forget to like, subscribe, and share with your friends.